Hello friends, today we will discuss all the numericals of chapter motion. So let's start. First question is, an object has moved to a distance. Can it have a zero displacement? If yes, support your answer with an example. Yes, of course. If we are moving along a circle and start with a point and end up with the same point, in that case, our distance will be the whole circumference, that is 2 pi r, but the displacement will be 0 because the initial point and final point are same. Now, second question. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. So, time is given 40 seconds and side is 10 meter. It means 4 side will be 4 into side, that is 40 meter. Okay. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial point? First of all, we will calculate the speed. We have distance 4 into side 40 meter. Speed we have time is given 40 seconds, so speed will be 40 by 40, that is 1 meter per second. Now we have to calculate the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds. So first we will convert this minute into second, that is time will be 2 minutes 20 seconds is 2 into 60 plus 20, that is 140 seconds. Now we have the speed already we have calculated. Now distance will be speed into time, that is 140 meter. Now, but we have to calculate the displacement. So we will first calculate the rotation, number of rotation. So that number of rotation will be distance divided by that 4 into side perimeter of the square. That will be 7 by 2, that is 3.5. This 3.5 means 3 complete rotation. For complete rotation, displacement will be 0. And this half rotation, for half rotation we have to calculate the displacement. So the rotation, half rotation, the farmer has moved 3 rotation and half rotation. So for half rotation, if the farmer has started from this point, he will end up with this point. In that case, displacement will be from this point to this point. Okay. If he has started from here, then of course he will end up with somehow here. In that case, displacement will be this line. So we will calculate the fastest displacement. Like if the farmer has started from this point and ended up with this point, half rotation, right? So displacement will be in that case this line. Okay. For this line, we have for displacement, we will calculate this line by using Pythagoras theorem. This is right angle, right? We have sides 4 meter, 4 meter. We will calculate by using Pythagoras theorem. Displacement will be of 10 square plus 10 square. Answer will be 14.4. Okay. Now, which of the following is true for displacement? Okay? For displacement, like displacement cannot be 0. Displacement can be 0 because if the initial point and final point will be 0, displacement in that case will be 0. So its magnitude is greater than the distance traveled by an object. Never, the magnitude of displacement will never be greater than the distance. It may be same, but never be greater. Distinguish between the speed and velocity. So we know a speed is distance traveled by an object in a given interval of time. It's called a speed. And velocity is displacement traveled by an object in a given interval of time. We can also write speed is equal to distance by time, velocity is equal to displacement by time. Speed cannot be negative, but velocity can be negative, positive, or 0, whatever. But the speed cannot be negative. Maybe 0, maybe positive number, but never be negative. The speed does not change the change of direction of motion. Of course, the velocity can change with the direction of motion. Under what condition is the magnitude of average velocity of an object is equal to the average speed? Of course, we know speed is equal to distance by speed. Velocity is displacement by time. So if distance and displacement both are same, in that case, average speed and average velocity will be same. What does, now next question, what does the odometer of an automobile measure? It is an instrument which is used to measure the distance traveled by the vehicle. Now, what does the path of an object look like when it is in uniform motion? If the object is in uniform motion, the path will be like straight. Okay. Now, during an experiment, a signal from a spaceship reached to the ground station in 5 minutes. Okay. This time is given 5 minutes, that is 5 into 60 minutes. Yes, that will be 300 seconds. Okay. Now, what was the distance of the spaceship from the ground station? The signal travel at a speed of light, that is this. Okay, speed is given, time is given. We have to change it in second. Okay, speed is given, time is given in second. Distance is equal to speed into time. What will you say a body is in uniform acceleration and non-uniform acceleration? Uniform acceleration, the rate of change of velocity is equal in equal interval of time. In that case, the body is in uniform acceleration. If the rate of change of velocity is not equal in equal interval of time, in that case, body is in non-uniform acceleration. Okay. Our next question. A bus decreases its speed from this 80 km/h to 60 km/h in 5 seconds. It means initial velocity is 80 km/h and final velocity is 60 km/h, and time is also given 5 seconds. Find the acceleration of the bus. First, we will change this 80 km/h to meter per second, right? That is how we have to multiply it with 1000 divided with 3600, that is 60 into 60. Okay, then it will convert it into 22.22 meter per second. This is our initial velocity. This is our initial velocity and this is our final velocity. Okay. Okay, now we know the formula. Acceleration is v minus u by t. By substituting the formula, we will find the answer. Okay, now a train starting from a railway station and moving with uniform acceleration. A train is starting from a railway station and moving with uniform acceleration at a speed of 40 km/h in 10 minutes. Find its acceleration. Time is given 10 minutes, converted in second. Speed 40 km/h converted into meter per second. And a train is starting from a railway station. It means at first it was in rest position. So initial point is 0. We have u is equal to 0, v is equal to 11.11 meter per second. Time is also given. So we can find out the acceleration by using formula. Okay. Now, what is the nature of distance time graph for uniform and non-uniform motion? This kind of graph I've already told you in previous video, right? For non-uniform motion, this kind of graph. Now, what can you say about the motion of an object whose distance time graph is a straight line? If distance time graph and the graph is a straight line and parallel to the time axis, it means time is increasing, but distance is constant. If the distance is constant, it means the position of an object does not changing. It's not changing. It means it is in rest position. Okay. So I think that was object is in rest position. What can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? If this like this, if the graph is like this, speed is constant, it means object is in uniform motion. Okay. Same speed is continuing, right? So what is the quantity which is measured by the area occupied below the velocity time graph? If we have this kind of graph, like for calculating the area of this area, what we will do? Velocity into time. Well, we know velocity into time is equal to displacement or distance, right? A bus starting from a rest means u is equal to 0. With uniform acceleration of 0.1 meter per second square. Acceleration is also given for 2 minutes. Find speed acquired and distance traveled. No problem. Initial velocity is 0. Acceleration is also given. Time is 2 minutes. Converted into second. 1 millisecond. Now first speed acquired. Speed is equal to u plus at. By substituting value, we will find. Now distance ut plus half at square. By using this formula, we will get the answer. Okay. Now, a train is traveling at a speed of 90 km/h. Okay. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Train is traveling at a speed of 90 km. It means initial velocity is 90 km per hour. And brakes are applied to produce uniform acceleration. Acceleration is minus 0.5 meter per second square. How far the train will go before it is brought to rest? It means final velocity is 0. We have to calculate the distance. Okay, u is 90 km per hour, converted into meter per second, 25 meter per second. Acceleration is also given, final velocity is also given. We know v square is equal to u square plus 2as. By substituting the numbers, we will find the answer. That is 6.5 meters. A trolley, while going down in an inclined plane, has an acceleration of 2 centimeters second square. Now, 2 centimeters per second square. What will be its velocity 3 seconds after the start? Okay. Acceleration is given. Okay. Acceleration is in centimeter per square, centimeter second square. So we have to convert it into meter per second square by dividing it by 100. Okay, it will be 0.02 meter per second square. Now, trolley while going down in an inclined plane, it means initial velocity is 0. First, the first trolley was in rest position, then it will go down, right? So initial velocity is 0, final velocity we have to calculate, and time is 3 seconds given. We know the formula: v is equal to u plus 80, v is equal to u is equal to 0, so v is equals to 80. Now by substituting the value, v will become 0.06 meter per second. A racing car has a uniform acceleration of 4 meter per second square. Acceleration is given, but what distance will it cover in 10 seconds? Time is also given after start. This is covered. A racing car. Racing car, it means first it must be rest position. So u is equal to 0. Time is given. Acceleration is given. By using formula s is equal to ut plus half 80 square, we will got the value and answer. Now next question. A stone is thrown in vertically upward direction with a velocity of 5 meter per second square. Okay, if the acceleration of a stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone and how much time it takes to reach there? So a stone is thrown in vertically upward direction with a velocity of 5 meter per second. So acceleration is given. Acceleration of the stone during its motion is 10 meters per second square. Okay. As the stone reaches in its final position, in that case the velocity will be 0. So final velocity is 0. Initial velocity is 5 meter per second. Okay. Now by using formula, v is equal to u square plus 2as, we can find out the distance, the height. Okay, so height will be 1.25 meter, 1.5 meter. Now time taken by the stone to reach the height, we will find out this by using formula v is equal to u plus 80. So time is p minus q by a. By substituting the formula, we will find out the answer. Okay. Now, an athlete completes one round of circular track of diameter 200 meter in 40 seconds. Diameter is 200 meter. It means radius is 100 meters, and circumference is 2 pi r, and time is 40 seconds. What will be the distance covered and displacement at the end of 2 minutes 20 second course? We have circular motion. Formula of circular motion is 2 pi r by time. So 200 pi by 40, because radius is given, distance is given, time is this, we can find out the velocity. Now we have to calculate the displacement at the end of 2 minutes 20 seconds. First we will convert this 2 minutes 20 seconds into seconds. It will be 140 seconds. Okay. Now distance is circular motion into time. in the 140 second, the distance covered is 2200 meter. Now for displacement, again we will calculate the number of rotation. Okay, so we will divide this distance divided by the circumference, that is 2628. Again the answer will be 3.5. It was just like a previous question, so it's the same, but in this time we know the for three complete rotation we have displacement is 0, but for the half rotation the displacement will be diameter, and diameter is 200. Now next question. Joseph jogs from one end A to the other end B, okay, of a straight line 300 meter road in 2 minutes 30 seconds. From A to B, the distance is 3 meters, and then turn around and jogs 100 meters back to the point C in another 1 minute. What are the Joseph average speed and velocity in jogging from A to B and then from A to C? From A to B, this is very clear. Time is given 2 minutes 30 seconds. That will be 150 seconds. Distance is also given 300 meter. Okay, we will find out the average speed, that is distance by time. 300 by 150, that is 2 meters per second square. For average velocity, we have in this case displacement and distance both are same. From A to B, there is no any other shortest distance, the same distance. The displacement and distance both are the same. So again, average velocity is also displacement by time, that is 300 by 150, which will 2 meters per second. Now, in case of B to C, we have distances from A to B, then C. The displacement is only A to C, right? So in case of from A to C, the average speed will be total distance, that is 300 plus 100, and total time 150 plus 60. That will become 1.9 meter per second. Average velocity displacement by time. So we will take only this distance. This one is displacement, right? And this one is A to B is 300 and B to C is 100. So this will be 200. Okay. So right, 200 minus 100, that is 200 by 200, which will become 0.95 meter per second. Now next question. Abdul, while driving to school, computes the average speed of his trip to be 20 km per hour. On his return trip along the same route, there is a less traffic, and average speed is 30 km per hour. In returning, the speed will become 30 km per hour. When he was going, the speed is 20 km per hour. What is the average speed of Abdul's trip? Take the distance PD. While Abdul was driving to his school, the distance between his home and school will be D in both cases. So the distance will be D. Now, when Abdul driving to school, speed is 20 km per hour, right? And time is distance by speed, that is D by 20. Next, in another case, speed 2 is 30 km per hour. In returning case, and time is D by 30. Okay, we have to calculate the average speed. We know average speed is total distance by total time. Total distance will be when he was going, that is D, again coming, that is D plus D, which will become 2D. Okay, and total time is T1 plus T2, that is D by 20 plus D by 30. So total time will be 5D by 60. By substituting the numbers in this formula, average speed will be total distance by total time, that is 2D by 5D by 60. Finally, it will become 24 km per hour. Okay. Next question. A motor boat starting from the rest means u is equal to 0 on a lake, accelerate in a straight line in a constant rate 3 meter per second square. It means acceleration is 3 meter per second square for 8 seconds. Time is also given 8 seconds. How does the boat travel during the time? This is very easy. I substitution the value in this formula. Yes, it's equal to ut plus half it square. We will find the answer. Okay. Next question. A driver of a car traveling at 52 km per hour applies the brake and accelerates uniformly in opposite direction. The the car stops in 5 seconds. Another driver going at 3 km per hour. In another car applies his brake slowly and stop in 10 seconds. On the same graph paper, plot the speed versus time graph for two cars. Which of the two cars travel farther after the brakes were applied? Okay. In first case, the car is traveling at 52 km per hour. We will plot the graph of speed and there is time. Okay, speed time graph we will make. Now, first the car was traveling at 52 km per hour. Okay, so first we will find this 52 km per hour. Okay, and then brake applied. This is our initial velocity. Final velocity is 0. Okay, and the time taken between this is 5 seconds. Okay, for this 5 seconds, the speed will from 52 to 0. Okay, and time will be from 0 to 5. So this kind of graph we will make. For another car, is at the start initial velocity is 3 km per hour. So initial velocity maybe it will be here, right? And then it will go to 0 in like this. The graph will be like this, and it is clear from the graph that the area covered by the line A, this line, is more than the B. So of course the car traveled. So car A is traveled faster after the brakes were applied, because earlier we have seen that the area covered is says about the distance, right? Because it is distance time graph, so the area will say about the distance. Next question, in figure 8.1 shows the distance time graph of three objects A, B, and C. Study the graph and answer the following question: which of the three is traveling fastest? So B is fastest. It is lesser time than that of other two lines to reach the same distance of 12 km. Of course, at this point, A, B, C, all three are at 12 km. Okay, but the time taken by B is less. C must take more than 1.6 seconds. Time is also bigger. The laser time is taken by B. So since speed is, so this B is fastest than the other A and C. Okay, time is inversely proportional to speed. Now next question: are all three ever at the same point on the road? No, because if they meet, it must be shown in the graph, not a single point where all three lines are meet. Okay, all three lines, because here the meeting point, but only A and B intersects. This point B and C intersects, but there is no any point where A, B, C all three will intersect. So if it is meet, then it must be shown in the graph. But if all three lines don't intersect at any point, it means all three are never meet at the same point on the road. How far has C traveled when B passes A? Okay, first we will see when B passes A. Okay, B passes A in this point. Okay, in that time C is at 8. Okay, distance is 8, but he has started at this point, not from 0. Okay, so we have to calculate this distance is this minus this one. Okay, so first we will know that this, first we will calculate this unit. Okay, for 4 there is 1, 2, 3, 4, 5, 6, 7. 7 unit boxes. It means 1 unit box is equal to 4 by 7. Okay, so what we will do, we will minus this 8 minus 1, 2, 3, 4. 4 by 7, right? From 0 to 4 there are 7 unit boxes, so 1 unit is equal to 4 by 7. Okay, and B passes A, the line C is at 8 from the origin, right? But C started this journey at the unit 4, so distance traveled by C is 8 minus 4 into 4 by 7. Okay, for 1 unit is equal to 4 by 7. and we have to minus 1, 2, 3, 4 units. So 4 into 4 by 7. Okay. So the answer will be 5.71 kilometer. How far we traveled by the time when it passes C? Okay, then how far has B traveled by the time it passes C? When B passes C, we will see B passes C. Yeah. Okay. The distances 1, 2. 2 more units than 4. Okay. Nine. Here, okay, we will count this unit boxes. Okay, there are 7, 8. So 4 by 7 into 9. It will become this. Now, question number 7. A ball is gently dropped from a height. Gently dropped from a height. It means initial velocity is 0. Then from height of 20 meter, it means distance is 20 meter. If its velocity is increases uniformly at the rate of 10 meter per second square, acceleration is also given. With what velocity will it strike at the ground? After what time will it strike the ground? We have to calculate first final velocity. Okay, u is equal to 0, distance is given, acceleration is given. By using this formula, v square is equal to u square plus 2as, we can calculate the final velocity. Okay, then we have to calculate the time. By using this formula, v is equal to u plus at. By putting the values, we can calculate the time. Okay. The speed time graph for a car is given, shown in a figure. Speed time graph. Find how far does the car travel in first 4 seconds. State the area on the graph that represents the distance traveled by the car during the speed. It's very easy. For first 4 seconds, this is time graph. We will set this part distances. So speed into time. That is 6. Speed is 6. Which part of the graph represents uniform motion of the car? Uniform motion, when motion is uniform, is speed is constant. So from this point, speed is constant. So when speed becomes constant, after 6 unit of time, 6 seconds, the speed is constant. Body is in uniform motion. Now, state which of the following situation are possible, and give an example with each of this. An object with a constant acceleration, but with 0 velocity. It will happen when an object is thrown upward. Then at the maximum height, the velocity of the body will be 0 at that instant, but acceleration due to gravity is exerted. So in that time, acceleration is possible, and the velocity is 0. Okay. So an object, next question, an object moving with an acceleration but with uniform. Yes. When a body is moving in circular direction, the body is moving in uniform velocity, but it exerts acceleration in towards the center of the circle. Now, an object moving in a certain direction with an acceleration, perpendicular direction. In the same case, like if a body is moving in circular direction, the acceleration is always towards the center, which make 90 degree to the tangent of the circle. Okay, so in this case, when an object is moving in circular direction, path is along the circle tangent, but the centripetal acceleration is toward the center of the circle, which is perpendicular to the tangent. Okay. Now, an artificial satellite. Next question. An artificial satellite is moving in a circular orbit of radius 4250. Okay, radius is given. Calculate its speed. It will take 24 hours to revolve around the sun. Time is also given. You know circular motion, formula of circular motion 2 pi r by t. By putting value, we get P is equal to 2 pi r by 24. The answer will be 2.070 meter per second. Okay, we have completed all the numericals and the question answer part. If you want the PDF of this file, please comment me your email ID in my inbox. I will send you the PDF file. Thank you. That's all for today.